Hi, everyone. Thanks for having me here. So let me get a feel for the audience before I get started. I might deviate from the slides tremendously depending upon who's in the audience. So show of hands, how many people in the audience here are practitioners or leaders of practitioners for software security? Okay, about half the audience. That's pretty good. Okay. How many people are in research? Okay. So a smaller number. So missing about a fourth, I think, there. So anyone want to shout out what they, what is that? Business development. Oh, but you work for a company that's in the practitioner space, so that counts in that bucket. Anyone else I'm missing? Big audience. Okay, well this is good. Then I'll stick with the slides for the most part because it is really geared towards the folks that about half of you are here. So the beatings will continue until morale improves. So this is the way we do application security today, basically. We basically try to beat up the developers. We're constantly calling their baby ugly all day long. And how effective is that going to be at improving morale? Not very. And so I'm going to give you a different way to basically approach this, not the William Bly way to do it. So I have a bunch of logos that are going to come up here. Any of you Hokie fans by any chance? Any Virginia Tech? There you go. Go Hokies. Any UVA folks in the room? Okay, you got to leave if you are. So anyway, I was at Carnegie Mellon for 7 years. I was a founding director of the Scilab there. We funded Rick Linger's function extraction work. I was the founding, I launched the Build Security In initiative there with Newport Davis and Gary McGraw. And Gary went on to basically evolve that into the BSIM. So how many folks have heard of the BSIM, Build Security In Maturity? A few of you. So it's still around. But my experience with that work left me depressed. I basically was very upset. I came to Carnegie Mellon. I left my successful startup business because I really thought we had a chance to really get developers, engineers to take more ownership of the security of the products that they were building. And the Build Security Initiative was that vehicle I thought we could make that happen with. But after several years of trying, we had almost no uptake. We didn't change anything about the way software was being built. And it didn't look like we were on the trajectory to change anything. So out of that frustration, I left cyber. I went to go work as an agile transformation consultant. I got qualified, and why did I do that? Well, agile at the time was a movement that was changing the way software development was being done. And I thought if I could just learn the tricks of how they got that to work, how did they get attention, how did they figure out how to change people's minds, which then changed their behavior, then we could possibly change the world and make more secure software out of it. And so I became a student of developer psychology, development team sociological impacts, and then later became a student of organizational pathologies. So those three ologies, sicknesses of organizations that prevent developers from doing it the right way, the way we should. So that's essentially my background. As you heard, I'm an active developer still, so I'm not just practicing what I preach, I'm not just preaching, I'm practicing what I preach. Okay, so how many of you, everyone here has probably heard of the phrase DevSecOps, right? You know, anyone not heard of the phrase DevSecOps? No, nobody's going to raise their hand on not. You never heard of it? Okay. So one definition that I hear, you know, have you heard the quote that all good ideas become movements, and then movements become businesses, and then businesses devolve into rackets? Well, the DevSecOps movement has become a racket, and it's been redefined as slapping DevOps lipstick on traditional security thinking, and it isn't very effective that way. So that's not what I mean That's not, when I wrote the original DevSecOps manifesto, that is not what I meant when I wrote it. I basically borrowed the build security and guiding principles and wrote the DevSecOps manifesto from them. But this is really what I mean, and it's got these three elements to it. First of all, it's empowered engineering teams taking ownership of the security of the products that they're building. You build it, you run it, you build it, you secure it, is sort of the concept. While using DevOps, and by DevOps I don't just mean you have a CI tool and you have this thing you call a pipeline, whether it really meets all the criteria for an effective pipeline or not. What I really mean is the cultural aspects of DevOps, and those are defined by Gene Kim most eloquently in the Phoenix project as flow, feedback, and a culture of experimentation and learning. Flow has been recently rebranded as sort of systems thinking, and it really wasn't, it was thought to be systems thinking. Anyway, these are cultural concepts. I'm going to touch on these obliquely as we go through the rest of the talk here. But the bottom line is that you got to never forget that the value that software development provides to the organization that they work for and society is in delivering software. And so whenever anyone says security first, I go, I pull my hair out. You can't be security first. If you have no customers, you don't need any security. If you have no users, why? Security is not first. You have to produce a product. You have to produce software that's useful. Now, you can say security at the same time as you produce a product, but you can't do security before that. Zoom is a great example of doing this well. At the beginning of the COVID movement, Zoom got, basically thrown under the bus by the cyber community because they had made a conscious decision to open up a web server on every machine that was running Zoom that would listen to a click so that their users would have a great one-click launch experience. But that also exposed those systems to risk. They also, end-to-end encryption, end-to-end encryption degraded the quality of the video. So they would dynamically turn it off whenever they sensed that the quality of the video was being degraded. They favored user experience over security. They made a conscious trade-off decision between those things. Now, they eventually got those things better and they worked on it, but it's not security first. It's software value first, and it's security at the same time, a best case scenario with it. Okay, so DevOps has the promise of both better quality and better speed at the same time. As a matter of fact, the concept of DevOps really is founded on the idea that with better quality, you can get better speed. Without that high quality, you actually slow down pretty rapidly. You might get the first iteration out faster without better quality, but you won't get the later iterations out without better quality. Not going to go too much into that. I couch this as 4 questions you should ask for sort of seeing if this is good for you. The first one is your dev team ready? And I would say your dev team is not ready unless you have a decent suite, a starting suite at least, of end-to-end functional testing, integration testing. If you want to do it at the API level, that's perfectly fine. Playwright, Postman, Cypress.io are the tools you generally use for that. And a single end-to-end test is probably enough to get started. As long as they have it in the pipeline and it's blocking the merge, then that's probably good enough. And so that bottom line there is that, prior to the pull request merge decision, we're going to talk about that a lot because that is really the key to success here. But first of all, before we get into that, why do you need these functional test suites? Well, 2 main big reasons for them. First of all, everyone talks about supply chain security or software composition analysis or SBOM or open source security. These are basically all different names for roughly the same sort of things, tools and activities. So the dirty little secret is that everyone who runs SCA tools ignores the output of them for the most part, right? They don't upgrade because it's too costly to upgrade all the time. So why is it too costly to upgrade? Well, if you upgrade the version of the library you're using, you could break your software. And so there's a strong financial motivation to basically let yourself get behind. And if you get behind, so there's major, minor, patch in Semver versioning. So the first digit, like 1.0.2 would be, the first major version, 0 minor version, 2.2 patch level. If you get behind in a patch level, it's probably not that big of a deal because patches are not supposed to break functionality, so they're not likely to break. If you get behind a major, it could break. It's also not supposed to, but it's much more likely to break your app. But if you get behind, a minor. If you get behind on a major, it's the only reason you go from 1.x to 2.x is if you have backward breaking changes that you make. Otherwise, you do a minor. And so if you get more than a major behind, you're screwed when something like Log4Shell happens. You can't upgrade to the latest version, okay? So you have to be able to upgrade, stay current with it, and the only way you're willing to do that is if you have a robust functional test suite that tells you, hey, I just tried upgrading to the next version and it didn't break anything. Or I just tried upgrading to the next minor version and only one test failed and I looked at it and it took me about 5 minutes. I think we can fix that in about, a day's worth of work. And we should upgrade to that version. The situation you're in when you don't have that test suite is you don't know. And so when you don't know, you basically just let it ride until something bad happens. The second major reason is that, as Rick Linger was pointing out, static analysis tools are notoriously bad at, Rick, you're still sitting right here, is notoriously bad at analyzing source code. They get it wrong all the time, and it takes a long time. So some SAS tools do loop analysis and branch analysis better than others, but that's because they spend more time, compute resources on the analysis. And so static analysis tool vendors are constantly making this trade-off between speed and accuracy. And so the most accurate static analysis tool is 36 times slower, takes 36 times longer to run on the same code base as the fastest one, but finds 70 times more problems than the fastest one. So you got this sort of thing. And the slower one only has a 30% false positive rate, and the fast one has an 80% false positive rate. But 30% is even bad by itself. And that 70% was only, that 70 that it found was only half the ones that were in the product, that were actually in the product. So there's a different technology out that is runtime static analysis, essentially. It does the same sort of things, but it's doing it in the running product, and it doesn't suffer from the problems of static analysis. It runs at real time, basically slows your functional tests down by about 10% max, and it's perfect. It's never wrong. It can be incomplete, but it's actually very, very low, near zero false positives with that. They're called IAST tools. And so I would strongly favor IAST tools. The dirty little secret about implementing IAST tools, though, is that you have to have a functional test suite. If you don't have a functional test suite, there's nothing to exercise the app, and the analysis doesn't occur. So you have to have a functional test suite in order for IAST to work. So those reasons should be good enough to write. Quality should be good enough reason. So you're from a company named QA Consultants, right? So you work in the space of helping people write higher quality software with the concept that security is just a dimension of quality. So writing functional tests should help your quality. You know that. That's why you do it for the most part. Well, now I'm giving you double the reasons to write functional tests, and basically that's the security one. Okay, so I'm going to skip this slide because the bottom line of this slide is basically you in the security world need to consider that you can't have great security without great quality. and that you should be the strongest advocates in your organization for high quality software. If that means you have to spend budget standing up a pairing service for your developers so that you can implement the first functional end-to-end test in their pipeline, that's what you do. No, that's an engineering thing, that's a quality thing, that's a quality department over there, there's an engineering department over there, they should pay for that pairing service. No, your budget, security budget at Comcast, I was the head of application security at Comcast for 5 years, I stood up a pairing service that any team that wanted, we would help them implement their very first functional end-to-end test. My bosses were like, why are we doing that out of our budget? We should make them do it. No, this is important for us too, and we're gonna become known as the biggest advocates for quality in the entire organization. So you need this, in order to do this, you need to have a pipeline that does not just, I have Jenkins and it's running somewhere on our system. It has to have ephemeral build and test capability. So you have to be able to stand up the whole environment and run the tests, and you have to be able to stand these up ephemerally, meaning you could have 5 of them running in parallel in one moment, and 3 the next moment, and 0 overnight, and etc. If you have a dedicated QA environment, you won't be able to do the rest of what I'm talking about here. This is a key prerequisite in order to pulling it off. You have to have a functional test suite first, and you have to run that functional test suite in a completely ephemeral environment. This is a big engineering lift. This can't be done by the security group or the QA group. It's got to be done by the engineering group, and you got to basically, you know, make it a prerequisite for them to do this in order to move on. Okay, so I mentioned the pull requests earlier. So pretty much all development today is run with pull requests. In a pull request, you do code review, but you also run automated checks. Style checker, QA checker, security tool XYZ. In one of my open source projects, I have 12 different checks that run during the pull request cycle. And so these pull requests, these checks run before a human is asked to review the code. And if any of those fail, then the developer who submitted the pull request gets that feedback, and no reviewer's time is even wasted. So this is the way software is done today, pretty much universally now developed this way. Now, the quantity and the excellence of the checkers is not great at this point. It's usually just 2 or 3, and they're not always looking for security in those checkers. But it's getting better and better. More and more teams are implementing more and more of them, and pretty much everyone is using a pull request. Well, pull requests are great because I, as a developer, the code I wrote this morning, it's really awesome. It's the best code I've ever written. I'm really proud of it. It's really great. And nothing makes me more excited than seeing that code get merged into the product in the afternoon. So if I have an automated checker that reports back to me that I didn't do something right, I'm like, oh man, I better fix that. And if fixing that means I need to learn what an SQL injection is, great. Well, the thing that gave me the feedback provided me a link to a 2-minute video that explains what an SQL injection is and a little exercise where I can practice fixing them. Boom. I have learned how never to write SQL injections again before. And the only reason I was motivated to do that was not because someone made me go take a secure coding class. It was because I love that code I wrote this morning and I want it to be merged this afternoon. And so I'm willing to take my time out of my job to go do that so that that code gets merged this afternoon. So what does this look like? You know, you can define a set of practices for application development, for DevSecOps, for shift left, borrowing from these sources like NIST and SANS. But there's lots of problems with these sources. And pretty much the biggest problem is that they don't have the right context. They may be written for an earlier day or for a different audience, and they're not prioritized. And so this doesn't work. So instead, what I propose you do, and I host these workshops, this is a big part of my job. I can do them in a half day on site. I can do them over the course of a week if there's Zoom meetings and virtual Post-it note boards involved. But I bring the cybersecurity leadership, the AppSec leadership in the room, and I bring the most respected developers in the room, and we figure out what the top list of practices are together using this process. We put Post-it notes up on the wall. We identify which of those things is easy for a team to self-service do today and which are not. And the ones that are easy to do, we put at the top of the list to start working on right away. And the ones that are not, we put to-do list items on our part to build those things. And then we coach development teams with it, and we evolve the service. We improve the easy button, and we keep improving this list of practices. At the end, you end up with this half-day workshop, you end up with a list of practices that looks pretty much like this for the most part. This is probably about 2/3 correct for every one of these workshops I've ever hosted. This example is sort of like a merging of them, and it never deviates from this more than, say, 50, 60% of the items on there be missing or changed. We'll do that. But don't look at the details of the list. That's not what's important. What's important is the criteria that define this list. First of all, it starts with non-security engineering practices. You can't have great security without what? Great quality. So you have to be the biggest advocates for software quality in your organization if you want to have great security. So the first 4 practices on the list here are not security practices. They aren't all of good quality, all of good software engineering, but they're the 4 that are either prerequisites for these security ones or will make the security ones be more effective or more efficient to actually do. And so you can be the advocate for those things. You know, ephemeral build and test infrastructure and testing coverage are the 2 prerequisites I said. Those are the 2 things that are sort of up there. You had to basically have those 2 at Comcast before you got into my program. By the way, over the course of 5 years at Comcast, the first 4 years first year is like 10 teams, and then by the 4th year, I'd gotten to 157 teams. At the end of the year, when I went for the budget cycle, I showed that there was 1/6 as many vulnerabilities found in production for the teams that adopted were through my program. It was only 157 out of the 600 teams, though. That set had 1/6 as many vulnerabilities found in production, in addition to 1/6 as many, roughly 1/6 as many vulnerabilities after they went through the program than before they went through the program. Going through the program meant they adopted at least half of these top practices. That's basically the definition of going through the program here. And so by the time I left, the CISO had decided we are going to require every software development team to do it this way. And so we got the budget to shut down the old AppSec program, because I was essentially competing with the old AppSec program. And basically over the next year, 2 years, 3 years, they shut it down. I left after about a year. I was only there for about 5 years. But I had accomplished what I went to be, what I meant to do. So notice that it's prioritized and gamified. And I'm going to press this green button and hope that, okay, good. And it's not my clicker. So notice these numbers here. Those are points. If you, as a team, adopt this practice in the next 90 days, these are how many points you're going to get. And there's a leaderboard for the top end teams, depending on the size of your organization. We had a leaderboard of 10 for 100 and so teams. Leaderboard for the most improved in the last 90 days. We reward most improved much more than we reward the top scorers, the ones who have been the most through it. So there was also a leaderboard for the top scorers, but it was less emphasized until the end. I think they're emphasizing it more now, actually. Prioritization and gamification. So this doesn't just help you motivate teams to want to do it, it also helps them to make decisions. Oh, well, we could do this thing and get 15 points, but that's hard. Oh, but that thing is also a prerequisite for B1 through B4 where there's 38 points. Wow, that's the gateway to getting those. So you get them thinking about the order of the steps that they would get and which ones we're going to do now and which ones are easiest to do and which ones get us the most points. And you basically get them to start thinking, how can I win at this game? Developers are gamers. They love it. It works. You get no points for running a SAS tool or an IS tool or a SCA tool. No points for running the tool. You only get points for being clean at a certain level of severity. High or critical clean. Notice that. Critical clean for third-party code. Critical clean. And I have those broken down so that we didn't have one big bucket that said run security scanning tools and it's 38 points of the whole 100 points. You know, I have it broken down into little things so they can adopt them incrementally and get 12 points one 90-day period and another 12 points the next 90-day period and another 12 points. You only get points for getting and staying clean, and you make it easy. Okay, so what is the criteria for a good tool to use in this environment? Now, I work for a tool vendor, so take this with a grain of salt. I might be a little biased here, but first, the criteria is not biased, but the end conclusion is the one you might have to have me more convinced on. Basically, it's speed, as I mentioned before, because it's got to run fast if it's going to run in the pull request. Most teams have a limit of 15 minutes max to run a pipeline run. If it takes longer than 15 minutes, they have to re-engineer to make sure it goes under 15 minutes. Is that your limit at your organization? And some organizations say 5 minutes. And so speed. So you want tools that run fast. Some SAS tools take hours or days to run on significant code bases. They're not going to run those before the pull request. So IS tools are the only tools that consistently do that. Also, if you parallelize the test suite, they parallelize the analysis. And so it speeds up in proportion to how much you parallelize it. SAS doesn't work that way. There's no way to parallelize SAS. Now, SAS tools have a trick called incremental analysis that works sometimes. It's tricky, but it is helpful. It is useful. Checkmarks has a very good incremental analysis capability, by the way, competitor-wise. Accuracy, and this is where IAST really shines. Basically telling developers to work on something that isn't actually broken, waste their time, and then, that's time is money. But more importantly, it pisses them off, okay? They don't want to have their time wasted. This tool sucks. Get it out of the pipeline. It's slow and it's not accurate. It's wasting our time. Get it out of the pipeline. That's where a lot of the friction comes from. So favor IAST is the conclusion that I basically come to here. Last but not least, I'm going to introduce this concept of coaching. And anyone know who this guy is? Who is it? Ted Lasso. Who said that? Did you say Ted Lasso? Who's Ted Lasso? Tell us about Ted Lasso. Soccer. What does he know about soccer before he goes over there? Nothing. Absolutely nothing. What does he know about? What is he good at? Motivation. You have your hand up. The Foo Fighters video? I'm not sure, no. Because he rejected that actual process, one of the Foo Fighters videos, and used the very essence into one of their songs. Oh, really? So repeat that again. What is he good at? Motivation. Getting people to get better. Getting people to work better together. Getting them to improve, etc. That's the kind of people you need to hire into your organization. Cybersecurity experts, the people with those acronyms that say they're cybersecurity experts, typically are not this kind of person. They've got the two type of people that are left in those jobs after the first 90 days of working in them, because it's soul-crushing work. Basically calling someone baby's ugly all day and slowing down the process and yelling stop and being ignored. Nobody wants to do that job, right? Unless you like calling people's baby ugly all day long. And how good a relationship is that going to be? or you're basically just phoning it in, right? You know, you're just like, oh, it's a job, you know, I don't really care if you actually do the stuff I'm auditing you on, but, you know, I'm here to point it out, and it's your job to do anything about it. So that's the kind of coaching you want. You want those people using this list. Oh, I got too many clicks back. Using this list and saying, which one of these are you going to adopt in the next 90 days? You know, you only missed the leaderboard by 1 point last 90 days. It's a rolling window, though. If you did one thing in the next 10 days, I can come back and we can do a new assessment, and you can get on the leaderboard for that. You want the coach being that guy who's basically motivating the team to adopt these practices, but they have to do it themselves. This is going to take too long. Okay, so that basically is my talk. I have some software that I've written that helps you run this process. I mentioned that. The software I've written is called transformation.dev blueprint. If you go to transformation.dev, you can sign up for being on the beta list when it's available for beta. Right now, I only have it in closed alpha, so only companies that get my coaching directly, my consulting directly, get access to it. And so here's the final slide where the deal is. This is a little bit about the company I work for, but I'm out of time, so I'm not going to talk about that. So I'm going to do questions in a second here. And please connect with me on LinkedIn, and I can send slides and answer questions there. And I think we're going to do questions now. Do we have any time? One question. Okay. You had your hand up, John.
So one of the things from yesterday and today that has been really interesting and it kind of brought to focus for me at least has been just how hard some of the stuff is when you're dealing with legacy systems and thinking about like just these giant code bases that have been around forever, and you're like going there. So I think the practices you're outlining here are very progressive, modern, forward-looking.
Yeah.
What is your point of view if you're confronted with a giant pile of legacy code that maybe isn't full, you don't have full automated test coverage and all the rest of it? Like how would you attack that kind of challenge?
Yeah, so you can't ignore that, first of all. And I didn't talk directly about it. The list of practices you'd come up with would be different than the list of practices for that situation. So we actually had 3 sets of practices at Comcast. We had legacy code product. We had data-oriented products, things that had no UI but were processing data, and then the list you came, there's more actively developed application one. So you'd come up with a different list of practices. You'd coach them the same way, you'd still care about quality, you'd still care about rapid feedback, but the process would be a little different. There's also another trick, and I went back to the slide for my company. I also would implement runtime application detection and response. ADR basically is a new term. We launched a product at Black Hat yesterday that is labeled ADR, but it's related to our existing product that's been around for a decade here. So not only do we detect vulnerabilities runtime like an IS tool does, we actually block attacks. So if you just install that on your software, you get the feedback on what the vulnerabilities are in that legacy software, but you also get safety for attacks because it might take you a while to get to fixing those.